Hello, I'm Eric Snodgrass, Principal Atmospheric Scientist at Nutrien Ag Solutions, and I want to thank you for giving me some of your time today to talk about some of the major weather issues we're having across the country here through mid-March and what our outlook is for spring and early summer. To get there, though, I'm going to talk about what winter gave us, and that map you've been looking at over there on the right shows you the statewide average temperature rings for December 2019 through February 2020. And it's pretty hard to find a place across the United States here that saw below average, even near average temperatures. We spent much of that time period with only very brief shots at cooler air and on the whole very warm air. Tucking right there into the Midwest, we can see a lot of states having a top 10 or top 20 warmest winter so far on record. Precipitation's been an interesting story here. While things have been very, very dry out in the western part of the United States, specifically California, we've been quite wet east of the Rocky Mountains, with some states down in the southeast, specifically down there looking at Alabama and Georgia, having their wettest winters on record. Here in the Midwest, a lot of folks having much above average precipitation, and the big questions we have to ask ourselves are, is the pattern that we've seen so far going to continue? Is it going to change? And what does that mean for upcoming spring and early summer? Because that pattern's got us here in the last month or so. So this is mid-February through mid-March. We're looking at total accumulated precipitation. And we've seen quite an active storm track through the midsection of the United States, and we keep leaving these lingering frontal boundaries that set up right down here across the south. So just keep this in mind. Remember, this part of the United States right now is usually trying through mid-March to get a crop in the ground. We've been extremely wet, some locations picking up well over a foot to 18 inches of rainfall. That's rainfall, not snow, rainfall in this area. So we've delayed some of the spring planting efforts to the south. But when you take a look at that and compare it to soil moisture, this map really tells an important story. Where we have drought, down in southern Texas, over the Four Corners states, and here along the west coast of the United States. But our major river systems, including the Missouri River, the Mississippi River, and the Ohio River, and down here in parts of the mid-south and southeast, extremely wet in terms of soil moisture content right now. I just want to give you one case in point. I'm going to take you to the headwaters here in both the Mississippi and the Missouri drainage basin, right up here into parts of central North Dakota. And the video you're going to watch over here on the right shows you what that excess of soil moisture looks like. Now, the ground right now is relatively snow-free through mid-March, but as you see this guy pushing through here, his tracks just squeezing the water out of the soil, making for what will be a pretty decent spring flood fight in the north part of the United States. Now, compared to a year ago, this is what through March 2019 our calculated soil moisture anomalies look like. And this was just the beginning of what was going to be one of the wettest, if not the wettest, springs on record. Certainly a spring with holding the record for the most frequent systems moving through the mid part of the United States. That was capped off, of course, in the middle of the month. This was a year ago, to the date, today, on March 13th, when I'm recording this, to this massive low pressure system that raced through the midsection of the United States. It was one of the biggest that I've ever seen, and I've been forecasting the weather for over 20 years here. West to east, this sucker was almost 2,000 miles wide. North to south, over 1,500 miles wide. And as it moved through, look at how much snow we had on the ground a year ago. This whole area in through here showing snowpack, and we added to it all of this. Now, why I'm bringing this up about a year ago is because that particular event, as it came through and brought heavy rains to the Midwest, state of Missouri, Illinois, getting down into the lower Mississippi River Valley, but also look at all the rain that it put down here in parts of Nebraska, South Dakota, and Iowa. And what it ended up doing was starting us off on our major river flooding for spring and early summer of 2019. You can see the Missouri River right in through here with the major flooding that we saw due to this massive system. So this gets us to the end of this point here. That system right now gave us this icon on our billion-dollar weather disasters of 2019. That particular one right now is estimated to cost $10.6 billion. $10.6 billion in damages. And so even through the start of spring of 2020, remember, we have not repaired the infrastructure damage fully from that event. So let's get into it. What are we looking at? Well, over the end of the month of March, we are seeing what's called an omega pattern. And an omega pattern looks something like that, where a ridge pushes up into Alaska, in this particular case, and a broader trough sweeps down here into the western United States. Now, what's the consequence of a pattern that sets up like this in the upper levels of the atmosphere? This is the consequence. You see, here's the jet stream. Here's the subtropical jet stream. And we're going to continue to put down multiple rounds of rainfall from Texas all the way over to Kentucky and Tennessee. And here in the Midwest, we're going to see the northern side of many of these storm systems. And that's why you see, if I get rid of that last drawing, much wetter than average conditions across the midsection of the United States as we press forward here through the end of the month of March. Now, in terms of snowfall, we had gotten through much of March erasing our snowfall in this area. It was really just left over right in through here. But with the next few systems that are coming through, we can see here that by the end of the month of March, the probability of adding at least 6 inches of snow to the ground, well, it's high out here in California, where they desperately need the snow. Some of the peaks in the Sierra Nevada are over 200 inches in deficit before this snow falls. Adding a lot more to the Rocky Mountains, but look right here through the Central Plains. Probability of grabbing 6 inches of snow is relatively high in Nebraska, South Dakota, moving over into parts of Minnesota and Wisconsin. And just remember, we're adding that water to the headwaters of our major river systems. That's what I want to show you here. Okay, so we just think about what spring is going to give us. So let's get to the longer term here. Just here on March the 13th, we were released the brand new long-range outlook from the European model. And what we've got here is March 27th through April 27th. Now, during that time period, you might be tempted to see the midsection of the United States showing up on the drier side of the color spectrum. But what I want to tell you is with the strong subtropical branch of the jet stream coming in through here, and the fact that we see wetter than average conditions moving into the west coast, we will continue to see storm systems moving through the midsection of the United States. So when you look at this, remember that over a 1 month time period, to be about a ½ inch below normal on precipitation does not mean we won't get precipitation. It just simply means that the heaviest of the rainfall we're anticipating is going to be tucked away in a corridor right here from Texas, running through parts of the Mid-South and Southeast. All right. What about temperatures? Well, the flow pattern has been such that we pushed a ridge up into parts of the Arctic, push it up into Alaska, and that's allowed for the colder air to kind of spill south into the northern plains of the United States. And with that omega pattern developing, something like that, the split happens right here with the warmth to the south and the cooler air to the north and west. I think the country is going to be split north-south with almost a little bit of a west to east tilt on our temperature patterns as we progress into spring. Much of the eastern half and, of course, east half of the Corn Belt and the southern half of the United States, though, going to be seeing warmer than average conditions as we press through the rest of March and into the month of April. Now, if we look at bigger picture things, this winter has been quite interesting given the fact that we have seen our Arctic Oscillation Index so positive basically since the start of the new year. What has that done? That's given us a very strong, well-controlled, very stable stratospheric polar vortex. And the stronger and more stable that stays, well, it tends to not connect well with the troposphere, giving us long duration shots at colder air. And that's what we've seen, and we're forecasting that at least through the end of the month of March. But here's something I want everybody watching for late spring and summer. Okay, what is this graphic? It's showing you global wind anomalies. In other words, we're comparing the speed of the atmosphere, the net speed of the whole atmosphere, to the rotation of the Earth. Now, one of the things that helped 2019 be so wet in spring was going back to that time period, which I'm circling here. That's March, April, May, and June of 2019. We saw above average global winds. Those global winds then crashed in through summer way down here, and this is where we saw some drought creeping in, especially in September and October in parts of the Mid-South. But momentum has been building ever since. And here's a major difference between this year and last year. We saw peaks in the global wind anomalies here in January, and again at the end of February, and now the beginning of March. And it looks as though we might see these global wind anomalies begin to fall back off again. And if they do, that's a very good thing. That allows for the atmosphere to slow down, which makes it less zonal, which means less of a west to east pattern and more of a north to south pattern. And if it sets up in such a way that that allows for ridging in the midsection of the United States, we will dry out and warm up. So that's one big difference from a year ago. Here's another big difference. A year ago, we saw very warm ocean temperatures right inside here where I'm shading in. We don't have that this year. In fact, we don't have an El Nino or a La Nina signal at all through mid-March. We do have some warmer water that's piling up here, but that's quite typical if your trade winds are strong. And we're going to come back to that discussion in just a few moments. So before I get into summer, let's at least talk about what April, May, and June look like from our best global models. This is 7 separate models run in the United States. They're part of what's called the National Multi-Model Ensemble. We're looking at precipitation differences from normal for April, May, and June. Now we see during that time period that the model's favoring drier than average conditions here. Still a strong branch of the subtropical jet stream, but you notice a corridor right in through here that the NMME is picking up on a wetter pattern for April, May, and June. Now these models are good, but they're not great, and their performance accuracy at 3 to 4 months out is not well, as good as we would all want. What this model is doing is it's keeping persistence in place. In other words, it wants to keep bringing systems through where they've been going through, and that's what you see here. So let's add to this the European model. Now at this point, the European model is favoring the strong subtropical branch of the jet stream, which you can see the wetter than average conditions here pushing into the North Atlantic. But it does not feature that same thing here that the U.S. models we're talking about. Now the European seasonal forecast is considered the best in the business. And right now I think we need to keep an eye on the potential for wetter than average conditions down south. But I'll tell you something that these models struggle in doing. They struggle in finding pattern changes. They tend to be very persistent with their forecasts. So we're going to look at them. We're going to try to understand what they're saying, but we need to make sure that we don't give them too much weight in our forecast, okay? One thing we do know is that seeing near average to above average temperatures seems to be in all of our long-range forecast models. That's what's shown to you over there on the right. So let's come back to this figure. I want to talk about how we keep seeing warm water piling up here and stronger trade winds. Now, if those trade winds, denoted by that arrow, continue to stay strong, we will see water temperatures in this whole area cooling off. And if those water temperatures cool off and the trade winds, which again I'll circle here, remain strong, that would be indicative of more La Nina-like weather developing in early spring and early summer. And that's something we want to pay attention to. La Nina-like weather tends to slow down the global winds, giving us a better chance for having blocking. But if that blocking establishes itself over the midsection of the country by June, July, or August, we start to now have a discussion about extreme heat during that time and potential for drought. So just remember this. If we see cold water stretching in this vicinity, off the Baja of California, that tends to lead toward cooler summers here from Alaska to the west coast, and therefore heat building in the midsection of the country. So if we think about that, is there any indication that this is going to happen? At this stage, there are just a few clues. Some of our long-range models are saying, well, it looks as though we might see the emergence of some cooler water in here. But remember, you've got to get the trade winds to respond to that cooler water. And if so, you need to see it building here into the Gulf of Alaska as well. At this stage, if it doesn't, then that means the probability of us getting a hot, dry summer lowers substantially. So let's take a look at what that best global model in the world looks like, okay? Over there on the left, you can see that this summer, it does have a slight dry bias in the midsection of the United States, with wet conditions down here to the south. What about the NMME? Well, you can see they're trying to keep the drier conditions here and in the northwest. In fact, both models have it in the northwest, but not so dry here through the heart of the Midwest of the United States. Again, what's the accuracy of these long-range models? It's not as high as you would want it to be. It's below 50%, but it still gives us a clue as we look out. So we're going to have to blend this with our other ideas to try to develop here some sense of a long-range summer forecast. So these are the things I want you to look out for. Get these drawings up here. I'll just draw over here on the left. What we want to pay close attention to is in summer, generally we have ridging somewhere across the United States. If it happens over the west, that tends to give us northwest flow. So if the ridge axis is right here, tend to have northwest flow in a very stormy summer, which tends to be good for our crops. If it moves a bit farther to the east and sets up somewhere here, where the main ridge axis runs right into the Dakotas, we tend to be extremely hot and very, very dry. So I want you to watch for those two things with me as we progress forward through our forecast. But with that, we're going to wrap it up right here. Thank you for your attention. I hope spring is a good one for you and we get some wide open planting windows to get some work done. Thank you so much. We'll talk to you again very soon.